So we're going to be looking at approximately linear patterns. So the first thing you do when you try to find an equation that best models a situation that's approximately linear is we're going to want to graph the data. So I have a graph set up here. This is the height of a tree, and you can see that not every day was recorded, but you do have some heights here. So the first thing we're going to do is we're going to just graph each of these coordinates. So this would be the coordinate 2, 17, and obviously it's not going to be perfect, but hopefully somewhat. 3 and 22, 5 and 26, 9 and 37, 15 and 55, and then 16 and 60. Okay, so not a perfectly straight line. Are you seeing that? So you're going to definitely need a ruler for this. And we want to try our best to make a line that we think models this situation. So your goal is to kind of go in the general trend of the line. So you wouldn't want to put it like this, for example. I think that's kind of obvious. But you want to have about half of the values above and about half the values below. And if you can hit points, that's obviously ideal. So you can see here that looking pretty good. So I'm going to go ahead and draw a line that I think will match this pretty well. You're going to want to go all the way through the y-axis with your line. There we go. So now the line approximately models our situation. So the next step, once we've drawn our line, is to find some coordinates that are either on or near the line, 2 of them, that we can use to come up with a general equation. So, for example, here's a pretty good one, and if I look up in my table, I can see that that's the coordinate 322. And then, I don't know, do you think we should do this one, 15? Let's do this one, 9 and 37. So I picked 2 that are on or near the line. So the next thing I'm going to do is to find the equation of this line. I always need 2 things, the slope and the y-intercept. So the first thing I'm going to look for is the slope. Well, I know how to find the slope. I can either use a table or I can use the algebra method. Because our numbers might end up being a little bit funky here, it's going to be easiest to use the algebra method. So remember I have x and y, first point, second point, and remember we use y2 minus y1 over x2 minus x1. So then I have 37 minus 22, and then I'm going to divide that by 9 minus 3. Okay, so the first step is to find the slope. And I get 15 over 6, which is 2.5. So then I'm going to write y equals 2.5x plus b, because I want to find my start number. I can see that it should be somewhere a little bit less than 15, but I need to find my actual start number, so I'm going to use one of these coordinates to plug it in. I'm just going to pick this one. Remember, you just pick 1, and this is my y, this is my x, so I get 22 equals 2.5 times 3 plus b. 3 times 2.5, 7.5. And then I'm just going to subtract 7.5 from both sides, and I get 14.5 is b. And you can see it's just less than 15, so that makes a lot of sense. So the equation of this line would be y equals 2.5x plus 14.5. Okay, now what does this tell me about the height of the tree? So it tells me our starting number, remember, would be at day 0. So it would tell me that the height of the tree is about 14.5 centimeters when I first plant it, and that it's growing by approximately 2.5 centimeters per day. So there's one example to show you how to find the equation that best fits an approximately linear situation.